Yes, good morning students. In the previous class, we have started the transistor amplifiers, and in that transistor amplifier, we are discussing about actually what is the meaning of amplifiers, and also what is the main function of amplifier. And what is the necessity of amplifier, and actually what is there in that amplifier. It means as we know already, we discussed in the yesterday's class, the amplifier is an electronic device and it will amplify the signal, or it will increase the, or it will strengthen the, or it will boost the weak signal. But important thing, without changing the shape or frequency of the signal. That is something that your amplifiers. And also yesterday I said, in general meaning amplifier, the amplifier will increase the power of an AC signal. In our amplifiers, the amplifier will increase the power of an input signal. And I said how actually the amplifier will amplify the signal, or how the amplifier will increase or strengthen the weak signals. But as we know, according to your conservation of energy, energy cannot be created, cannot be destroyed, but you can transfer. Especially yesterday I said, this is your block diagram of amplifier. In this amplifier, as we know, you are having the input section, also you are having the output section. It means this is your VI, this is your VO, and also you are applying the DC source. It means, as we know, if you apply very small signal, we will get the very high signal, or we get the very strengthened signal. Especially I said in the yesterday class, you are applying 0.1 as an input, but you get output as nearly about 5 volts. But according to the conservation of energy, energy cannot be created, cannot be transferred. Especially we are giving the input as very small voltage, but how will you get the very high output voltage? It means according to the, you are not you are satisfying the conservation of energy, and especially according to conservation energy, here what happens in case of amplifiers means the DC, you are converting, you are transferring the energy from one form to another form, because as we know the conservation energy cannot be created, cannot be destroyed, but we can transfer. Here also we are applying very low voltage as the input, but we are getting very high voltage as the output. But how we get the high voltage as output? That is because of the DC source. It means you are transferring signal from, you are transferring energy from one form to another form. You are transferring the energy from one form to another form. It means, as we know the conservation energy cannot be created, cannot be destroyed, you can transfer. Here also you can transfer the energy from DC source to the AC source. You are transferring the DC source to the AC source. It means, as we know, in your input you are applying the AC signal, and also you get the output should be also in the AC signal. But as I said, the output, how much the output amplified, the amplified output, that depends upon the input signal. That depends upon the input signal. This is the most important thing in your amplifiers. Yesterday we discussed in detail about that, and also I given good examples basics how to in general, or I given good examples of how to what is the actual meaning of your amplifiers. And also I said the amplifier, it is an amplifier or amplification, it is a Latin word, that is in Latin we call it amplifier, that means expand or enlarge. And also I said in 1906 the Lee Forest, they invented the practical amplifier by using the vacuum triodes. And also we have discussed about transistors. In your transistors, you are using the, as we know, transistor, the most important application transistor is nothing but our amplifiers. And yesterday we discussed about what is the condition of your normal condition of amplifier. And also I said about in your amplifier that consists of a active device and a passive device, and as a DC biasing, because without biasing it is not possible to make it any device on, or we are not getting any current or voltages. If you want to input voltage, input current, or output voltage, output current, we want the biasing. It means once you are done the good biasing, then you can apply the input signal as a weak input signal to the input section, and we'll get the, for example, if we are going for the transistors, yesterday I said in the emitter base section, if you apply very small signal, we'll get the very high signal and output, we'll get the collector emitter section. It means in your normal condition of amplifier is nothing but we want the emitter base section, emitter base section, base junction should be forward biased, and also collector base section should be reverse biased, If these two conditions satisfied, then only your transistor acts as an amplifier. Because you are studying in this topic about transistor amplifiers, it means how we can use the transistor as amplifier, as you have studied already. Only in the active region, your transistor acts as an amplifier. And as we know already, what is active region? Nothing but in the active region the input should be forward bias, or the emitter base should be forward bias, and the current base should be reverse bias. If this condition satisfied, then only your transistor acts as an amplifier. This is about the normal condition of your amplifiers. And also, as we know already, if you want the faithful amplifications, what is called your faithful amplification, and what is the condition of your faithful amplification? Next you go for the, yesterday I said already, faithful amplification, nothing but, as we know already, in your amplifiers we are increasing, or you are strengthening, or you are boosting the signal. The signal will be current or voltage, or it will be the power. And also, as we know already, only for your faithful amplification, the faithful amplification nothing but the process of strengthening the weak signal, or the strengthening the or magnitude of the weak signal, or we are increasing the amplitude of signal. The important thing, without changing the shape or without changing the frequency, only you are increasing or you are strengthening the amplitude of signal. That is something but your faithful amplification. As I said, amplification nothing but it is a process of strengthening the weak signal without changing the frequency or without changing the shape of signal. It means in your faithful amplification nothing but the process of increasing or the process of strengthening or the process of increasing the amplitude of the signal, or you are increasing the magnitude of signal, weak signal, and without disturbing the other parameters. Only you are changing the amplitude, only you are increasing the amplitude of signal, and the frequency and the shape of the signal should be constant. That is something called your faithful amplification. And we know in the last class, for whenever you want the faithful amplification, the important thing is about, you studied already in your transistor biasing. In your this is your DC load line, this is your DC load line, and important thing for the, this is your Q point. Important thing for the faithful application is that you are giving more importance to Q point. Always the Q point should be in the middle of the active region. If the Q point may shift towards the saturation, or it may shift towards the cutoff, in that time you are not getting the correct output. Output will be distorted. Only you will get the faithful application. The condition is that Q point should be always in the middle of the active region. Always the Q point should be in the middle of active region. While constructing amplifier, we have to take care. The important thing is that the Q point should not vary. It should not shift above or below. Always there should be in the middle of the active region. And how to make it Q point should be in the active region, that is my using your biasing. It means in your faithful application, the important thing is that always the Q point should be in the middle of the active region, and also we are not changing the frequency, only you are increasing or strengthening the amplitude of signal. That is nothing but your faithful application. And also yesterday I said about what is called your what is the condition of faithful application. The first condition is nothing but zero signal collector current. Zero signal collector current. And the second one is about we want minimum emitter base voltage, emitter base voltage, that is at any instant we want minimum VBE. Also we want minimum collector emitter voltage. It means we want minimum VC and also want the minimum V. If these three conditions satisfied, then only your amplifier will get the output, will get the faithful application. This is yesterday, up to this you are studying in the last class. Now today we go for the another important thing is about classification of amplifiers. Classification of amplifiers. Classification of amplifiers. Actually, in your classification of amplifiers is nothing but depending upon the, it is also important question for your exam point of view, how we can classify the amplifiers. Actually, you can classify amplifier in different ways. It may be the depending upon the input signal, or depending on output signal, or depending upon the frequency, or depending upon the Q point, or depending upon the configurations, or depending upon the your Q point, or depending upon your coupling, depending upon the different stages, and depending upon the bandwidth. Now we will go for one by one how we can classify the amplifiers. It means In broad, we can classify the amplifiers depending upon the input signal. First, you go for the input signal. Input signal. As we know, according to the input signal, we can classify the amplifiers. As we know, in general, the input may be current or input may be voltage. The R, you can say, you can apply very small voltage or you can apply the very large voltage. First, the important types under the input signal. One is called your small signal amplifiers. Small signal amplifier. And second one is about large signal amplifiers. It means depending upon the input signal, it may be the small signal or it may be the large signal. We can apply it for the input section. It may be you can apply very small signal or you can apply the very large signal. And now we go for depending upon the output signal. Depending upon the output, what will be depending upon the output signal or depending upon the nature of the output. Right, about the nature of the output. Depends upon the nature of output. Yes, we know already. The output may be current or voltage. The output may be the current or voltage. It means according to the nature of output, we get the voltage amplifier, or it may be the current amplifier. It means this is by using input signal. It may be the small signal or it may be large signal, and depending upon the nature of output, what type of output we get. It may be the output may be voltage or output may be the current. Depending upon the nature of output, you can do the classification, the voltage amplifier or it may be the current amplifier. Now we go for the depends upon the frequency. Depends upon the frequency, you can classify the amplifiers. That is nothing but the important thing is about depends upon the frequency ratings or it depends upon the frequency. First one is about AF amplifiers. And second one is about IF amplifier. First I will write everything, then we will go for the explanation. IF amplifier. And next we are having the EF nothing but audio frequency amplifier. IF nothing but intermediate frequency amplifier. IF nothing but intermediate frequency amplifier. Then you are having the UF nothing but ultra high frequency amplifier. And also having the fourth one, very high frequency amplifier. The very high frequency amplifier. Also, we can go for especially you'll get audio frequency. Here you get the small change here. Go for the next. You are having the sixth one is about RF amplifier. That is nothing but radio frequency amplifier. and finally go for the, you have done the EF, you finally go for the SHF. SHF is super high frequency amplifier. Super high frequency amplifiers. It means depending on frequency, you have done the types of nearly about 6 types of amplifiers. First one is called AMPLIFIER, audio frequency amplifier, and next we are having the intermediate frequency amplifier. Then actually we get here we get radio frequency amplifier. Then we are having the very high frequency amplifier, then ultra high frequency amplifier, and also we are having the super high frequency amplifier. These are the types of amplifiers by according to the frequency. AF nothing but audio frequency amplifier, IF nothing but intermediate frequency amplifier, and AF nothing but ultra high frequency amplifier, VHF is very high frequency amplifier, and RF nothing but radio frequency amplifier, and SHF nothing but super high frequency amplifier. These are the classifications according to the frequency. Now we go for the according to the Q point. According to the Q point, we can classify the according to the Q point. We can classify the different types of amplifiers. One is called class A amplifier, class A amplifier, and next one is about class B amplifier, and next one is about class AB amplifier, and finally having the class C, class B amplifier. It means depending on where the Q point is there, especially in your studying in detail about this also called as power amplifiers. This also called as power amplifiers. In class A amplifier, class B amplifier, class AB amplifier, and class C amplifier, the Q point is in the different places. We go in detail about while explaining about all this. The important thing is there. According to the Q point, you can classify amplifiers. It may be class A amplifier, class B amplifier, or it may be class AB, or it may be class C amplifiers. This is about the according to the Q point. And now we go for the most important thing, as we know already. That is nothing but depends upon the configuration. Depends on the configuration. Depending on the configurations, as we know already, it may be the C amplifier, it may be the C amplifier, or it may be the CB amplifier, or it may be the CC amplifier. As we know, you have done the different types of configuration by using your transistors. As we know, in your in general, whenever we want to connect any circuit, we want 4 terminals, but as in your transistor I have only 3 terminals. And how to make it 3 into 4? It is very simple. You make it any one terminal common for input as output, and depending upon then you have read about different type of configuration. In the same way, we how to depends upon the configuration, how to classify the amplifiers. Especially in your common emitter, here emitter is common for input as output. That is nothing but the common emitter amplifier. And here base is common for input as output. That is nothing but common base amplifier. And here the collector is common for the input as well as output. That is nothing but the depending upon the configurations you have done the classification. It may be the C amplifier, it may be CB amplifier, it may be the CC amplifier. And as we know, I said so many times, in our overall common base and common collector, we give more importance to the common emitter configuration. And why we are giving more importance to the common emitter configuration? Because always we want What we want? What we want more? We want more I, and also we want more V. Also we want we want more V. We want more I. Also we want more P. It means we want more voltage. V nothing but more voltage. I nothing but more current, and P nothing but more power. That's why I said so many times in the overall electronics you are studying, are giving more importance to these three factors, these three parameters. One is called voltage, another current, and next one is the power. And that's why I said so many times for understanding of our electronics is called VIP. The subject electronics is called VIP because we are studying about voltage, current, or studying about the power. It means as compared to the common base and common collector amplifier, why you prefer C configuration or why you prefer C amplifier? Because in C amplifier you are getting more voltage gain, more current gain, and also more power gain. This is about you have done the classification, depends upon the configuration. That may be the common emitter, common base, or it may be the common collector. Now we go further, depends upon the coupling. Depends upon the coupling also you can classify the amplifiers. That is nothing but depends upon the coupling. First one is RC coupled amplifier. RC coupled amplifier. RC coupled amplifier. Second one is about transformer coupled. Transformer coupled amplifier, and finally the direct coupled amplifier. It means in this what is called coupling. The coupling nothing but you are connecting the input output. For example, RC coupling. In RC coupling amplifier, we are using the R and C to connect the input to the output. You are using the R and C to connect the input to the output, and here you are using the transformer to connect the input and output, and here you are using you are not using any, you are using directly on wire from input output. That is called direct coupled. Here you are using transformer to connect input output, and here you are using R and C. By using R and C connect one input to output. That is nothing but your by using the coupling you have done three types of amplifiers. One is called RC coupled amplifier, another is called transformer coupled amplifier, and finally last one is about direct coupled amplifier. Everything you are studying in detail in the further class. And next we go for the stages. According to the stages, how we can classify the amplifiers. One is called stages. As it is very simple, there are only two. One is called single stage. Single stage amplifier. Single stage amplifier. And second one is about multi-stage. Multi-stage amplifier. This also studying in detail. Especially in the single stage amplifier, you are using only one type of transistor and remaining passive components. Here you are using more than one type of transistor or FET, and that is called multi-stage amplifiers. Single stage, you are using only one type of amplifier. Here you are using more than one stage of amplifiers. You are using only one stage of amplifier. You are using more than one stage of amplifiers. That is called single stage amplifier, and that is lastly finally it is called as multi-stage amplifiers. And finally go for the according to the bandwidth. According to the bandwidth, you can classify the two types of amplifiers. One is called according to bandwidth. One is called narrow band amplifier, and second one is about broadband amplifiers. These are the different types of broadband and wide band amplifiers. Means by using the bandwidth, we can classify the two types of amplifiers. One is called narrow band, one is called the wide band amplifiers. These are the nearly I said about depends upon the 5 to 6 important parameters we can classify the amplifiers. Once again repeat. First is nothing but depends upon input signal. It may be the small signal amplifier, it may be the large signal amplifier. And second classification is about nature of the output. As we know, the output may be the current or output may be the voltage. And depends on that, we are on the voltage amplifier, we are on the current amplifiers. And then you are going for the depends on the frequency. It may be the audio frequency amplifier, it may be the intermediate frequency amplifier, or it may be the radio frequency amplifier, or it may be the ultra high frequency amplifier, or it may be the very high frequency amplifier. Finally, it may be the super high frequency amplifiers. These are the, you have done the classification, depends on the frequency, that is about the classification. Then you are going for the Q point. Depends on the Q point, where the Q point is in the output of a DC load line. It may be, depends on that, it may be class C amplifier, it may be the class B amplifier, or it may be the class AB amplifier. Finally, it may be the class A amplifier. That depends upon Q point, you can classify the amplifiers. And also you have done the classification, that is very common, we know, that is the configurations. It may be the common emitter amplifier, or it may be the common base amplifier, or it may be your common emitter amplifier. And then you go for the different types of the coupling. It may be the RC coupled amplifier, or it may be the transformer coupled amplifier, or it may be the direct coupled amplifier. And also you are talking about the stages. It may be the single stage amplifier, or it may be the multi-stage amplifiers. And finally, overall we are studying about the bandwidth. It may be the narrow band amplifier, or it may be the wide band amplifiers. These are the types of different types of amplifiers, or you have done the classification of the amplifiers depending upon the important parameters of your amplifiers. Now we will go for in detail about actually I said about what is called your small signal amplifier. What is called your small signal amplifier. What is called the small signal amplifier, and what is the importance of small signal amplifiers, and actually where we are using the small signal amplifiers. Actually, their name will be their meaning. Especially in your amplifiers, we are applying very small input signal. We will apply very small input voltage. Especially how we can write about small signal amplifier. In small signal amplifier, you are applying the input. You are applying the input voltage. The important thing, the amplitude of the input signal will be less than the Q point values. The amplitude of the signal will be less than the Q point values. The amplitude of the amplitude of the signal. You are applying some input signal of amplitude. That amplitude should be less than the Q point values of the transistor. That type of amplifier is called as small signal amplifiers. Don't confuse in every amplifier. you are applying some input signal, and especially you are applying some voltages. How much you are applying the voltages? Especially for your small signal amplifiers, we will apply the amplitude. That amplitude will be less than the Q point values of the transistor. That type of amplifier is something called the small signal amplifiers. Especially it means we can write the amplitude of the signal will be less than the Q point values of a transistor. It means in your small signal amplifier you are applying the input signal. That input signal has some amplitude. That amplitude should be less than the Q point value. That type of amplifiers we call as the small signal amplifiers, and it is also called as voltage amplifier. The small signal amplifier is also called as voltage amplifier. It is also called as voltage amplifier. Why it is called voltage amplifier? Because here in the small signal amplifier you are increasing the voltage level of the signal. Here in small signal amplifier you are increasing the voltage. You are having the more voltage amplification. You get the more voltage gain, or you get the more voltage amplification. That's what is called as small signal amplifier. Another name of small signal amplifier, it is also called as voltage amplifier, because in small signal amplifier you are increasing the voltage. You are increasing the voltage level of the signal. And actually where you are using this voltage amplifiers, especially in your radio transmitter receiver, you are using the initial stage of the radio transmitter receiver, you are using the small signal amplifiers. In the initial stage you are using the small signal amplifiers. And what are the drawbacks of your small signal amplifiers? Especially because of small signal you are having the very small voltage, and also having very small current, very small voltage, very small current. That's why what happens, we are having a very small power. We are having a very small power, especially that is nearly less than 1 watt. Less than 1 watt. In your small signal amplifiers, the power is very small. That is nothing but less than 1 watt. And also having the power efficiency also very less, and also the dissipation of power also very less. The dissipation of power also very less. The most important thing about small signal amplifier, it is used for only the voltage amplification. Only you are increasing the voltage. You are increasing the voltage level of the signal. Only you are increasing the voltage level of the signal. That's what is called as small signal amplifier. The small signal amplifier nothing but it is a type of amplifier. In this type of amplifier, the important thing, you are applying some input signal. That input signal very very small input signal, and it means that input signal magnitude or amplitude. The amplitude of the input signal will be less than the Q point value of the transistor. That type of amplifier is nothing but the small signal amplifier. The important thing about small signal amplifier, it is also called as voltage amplifier, because here you can only increase the voltage level of the signal, and also because of the development very small voltage, you get the very small current. That's why you are having the very small power handling capacity. Also you are having the very less power efficiency, and also you are having the nearly I said about less than 1 watt. The power dissipation also very less, and this is about the importance of small signal amplifiers. Now we will go for the large signal amplifiers. I will go for the large signal amplifiers. These are the types of amplifiers by using the input signal, by using the nature of the input signal. Next one is about large signal. Large signal large signal amplifier. And here also their name and their meaning. Here you are applying a very large input signal. In small signal amplifier you are applying very low voltage as an input. But here you are applying a very high voltage as an input. Here also the important thing is about you are applying some input signal and the input signal is having some amplitude, some magnitude. The important thing is in your large signal amplifiers, the amplitude of signal, the amplitude of the signal will be more than the Q point values, more than the Q point values of the transistor. It means the important thing is about in large signal amplifiers we will apply very large signal as an input, and in your large signal input you are having the amplitude of signal will be more than the Q point value of the transistor. This is so important. As in your small signal amplifiers, the amplitude of the signal will be less than the Q point value, but the important difference about large signal amplifier, the amplitude of the signal will be more than the Q point value of the transistor. This is why most important difference about small signal amplifier and about the large signal amplifiers. And also this large signal amplifier is also called as power amplifier. It is also called as power amplifier. It means here you are increasing the power level of the signal. As in your small signal amplifier, you are increasing the voltage level of the input signal, but in your large signal amplifiers you are increasing the power level of the signal. You are increasing the power level of the input signal. And you may ask the question, sir, how you are increasing the power? Because here you are applying the very large voltage. Because of large voltage you get large current, and once the current and voltages are more, you get the more power, or you get the power is more than P is equal to more than 1 watt. In your small signal amplifier you get the very small power, that is less than 1 watt, but in your large signal amplifiers you get the power that is more than 1 watt. And another important thing is about the large signal amplifier. We are using the last stage of the amplifier. As I said, where we are using the small signal amplifiers and where we are using the large signal amplifiers in your radio transmitter or receiver. In the initial stages you are using the small signal amplifier because of the voltage amplification. In the same way for your large signal amplifiers, it is used in the last stage of your radio transmitter receivers, because in the last stage we want more power, but increase the power level of signal. In that time you are using the large signal amplifiers. The important thing about large signal amplifier, you are having the more power, and having the power dissipation. You are having the more power dissipation. The most important thing is about power efficiency. The efficiency of the power will be very more. As I said, in your small signal amplifier the efficiency is very less, but in your large signal amplifiers you are having the more efficiency. You are having the more power efficiency. These are the importance of your small signal amplifier. Also you are having the large signal. Also it is having the more we can see about impedance matching. As in your large signal you are having the more impedance matching. It is also used for the impedance matching. These are the importance of your small signal amplifiers and also large signal amplifiers. And finally, we go for what is the major difference. This I said about what are the importance of your small signal amplifiers and also what are the importance of your large signal amplifiers. Don't confuse that name, it is their meaning. In your small signal amplifiers can apply very small input signal, but in your large signal amplifiers we are applying the very large input signal. It means, as I said, you are applying some input signal, that input signal has some amplitude. If the amplitude is very less than the Q point value of a transistor, that is nothing but your small signal amplifier. If the amplitude of signal is more than the Q point value of the transistor, that is nothing but your large signal amplifier. And also, as I said, in your small signal amplifier, you are increasing the voltage level of signal. It is also called as voltage amplifier. You have done only the voltage amplification. You are getting the large voltage here. In the same way, for your large signal amplifier, you get the more power. You get it is also called as power amplifier. You are increasing the power level of signal. In your large signal amplifier, you are increasing the power level of the signal. And we go for the difference, the major difference about small signal amplifier and large signal amplifier. As we know, the first important thing about you are applying very small voltage. You are applying very small input voltage. You will apply very small input voltage. Here apply very large input voltage. And the small signal amplifier is also called as voltage amplifier. It is also called as voltage amplifier, and it is called your power amplifier. The important difference about small signal amplifier and large signal amplifier, as we know in general, in your transistor, the base region is very light low, very thin. But in your small signal, the important thing, base region. The base region is thin. But in your large signal, the base region is thicker. And also in your beta value, here the beta value is less. I can write about here. The beta value is less, and the beta value is more. And here the power is more, the power is less, and here the power is more. And also here having the power dissipation, the power dissipation is low, the power dissipation is high. The power dissipation is high. And especially we go for another important thing is about the size. The size also very small in size, compact the size, compact in size, compact in size. It is or you can say very small size, small size. Here it is very more in size. These are the important about the small signal amplifiers and also large signal amplifiers. The most important thing is about the power handling capacity is very more for the large signal amplifiers, and the power handling capacity very less for the small signal amplifiers. It means the power efficiency is more for large signal amplifiers, is very less for the small signal amplifiers. And as I said about beta value is also very less for your small signal, is very more for your large signal. And also I said about power dissipation also very more for your large signal, it is very less for your small signal. These are the importance differences about small signal and also large signal amplifiers. In the tomorrow class I will cover the what are the important characteristics of your amplifier. As we know, we are having the most important parameters or most important characteristics of your amplifier are, it may be the current gain, it may be voltage gain, or it may be the power gain, or it may be the input impedance, or it may be the output impedance, or it may be your bandwidth. These are the important parameters of your amplifier that you study in the tomorrow class. Thank you.